So for the construct the understanding, this is on page 592. Off to the side, what we're going to do is write out some steps to help you with these questions. Because when you read these questions, these distance, speed, time ones, we're going to do applications of rational expressions today. We're going to look at 3 different types of questions. They're all types of questions that when you read them, you will get the initial feeling of being overwhelmed. Because they're very complicated sounding questions. So what we're going to do is we're going to break them down, look at some strategies to make them not as overwhelming and doable. So for distance, speed, time questions, that'll be the first type of questions that we're going to look at. What we're always going to do that's really going to help us, and we did this in 7.5, is we're going to set up a chart. Where you put distance, speed, time, and depending on what information you have, it's going to look something like this. Depending on the question, I think the first question, they've already given you a chart there. Edmonton to Grand Prairie, and then Grand Prairie to Edmonton. There's going to be a question where we go upstream and downstream. So the things that you're going to put up here are going to change, but this chart is going to stay the same. So we're going to set up our chart. Once we've set up our chart, the second thing that we're going to do is enter the data that we know. And choose a variable for what we don't know. We're only going to choose one variable. I didn't say choose variables, choose a variable. So the first thing that you don't know, it might be you don't know how fast they're going. You're going to put an S in for that variable. Okay? Because what we're going to do in our chart is write the entire chart with only one variable. So often after you've chosen a variable for what you don't know, you might still have 2 sections of this chart not completed. What you're going to do in number 3 to complete the chart is use your formulas for distance, speed, and time. Remember yesterday we talked about if we're talking about speed, you're going 100 kilometers per hour. You know that speed is distance over time. You can rearrange this and get time by itself. That'll be distance over speed. And you can rearrange this to get distance by itself. That'll be time times speed. And if you like V for velocity, in your other courses, you can use that instead of S for speed. It's up to you. Okay, so there we have those 3 formulas. This is the strategies that we're going to use for all of these questions. In the construct the understanding here, the chart is already made. So our chart is already made. We're going to start filling it in with what we know. Mario drove from Edmonton, Grand Prairie, and back a distance of 300 kilometers each way. 360, 360. That's data we already know. Mario's average speed was 30 kilometers greater on his return trip than his trip out. So now we have something we don't know. We don't know exactly what his average speed is from Edmonton to Grand Prairie, but we know that it's 30 kilometers greater on the way back. So if I introduce a variable here as S, this one will be S plus 30. Determine his average speed. We know his total time is 10 hours, but we don't know his time from Edmonton to Grand Prairie. We don't know his time from Grand Prairie to Edmonton. But this is where we use that step 3 where we use those equations. Time is distance over speed. So this one is 360 over S, and this one will be 360 over s plus 30. I guess I'm going to go back to what we wrote over here on the side. There will always be, as sort of a step 4, there will always be something in the question where you can create an equation using additional information from the question. The additional information in the question that they have is that the total time took 10 hours. So you're going to have to read through your question and say, where's the additional information that doesn't fit into my chart? His total driving time was 10 hours. How do I create an equation from this chart using that? Well, I know that this time plus this time has to equal 10. And now we go to our strategies from before. How do we solve rational equations? This could be 10 over 1. Do you want to use the multiplying strategy where we multiply to get rid of fractions? The common denominator strategy? Okay. So to get a common denominator between s plus 30, and 1, this one's missing the s plus 30. This one's missing the s. And this one's missing the s and the s plus 30. Now, if you multiplied the whole equation by s times s plus 30, all of these would go away, and we'd be left with 360s plus big number plus 360s equals, I'm going to do this in 2 different steps. I'm going to distribute the s first. I'm going to combine my like terms here. Please correct any mental math mistakes as I go along. And it makes a quadratic equation. So how do we solve quadratic equations? Make one side equal to 0. Subtract the 720. Factor out a 10, make it a little bit easier. Hello?
Is Brendan McLeod in class?
Yes, he is.
Could he please come to the office?
All right, he'll be right down.
Thank you.
Okay. Do you know your 1080 times table?
No.
108 times 10. I'll just steal 2 from here. It'll be 220 times 54. Does that work out yet? No, I'll steal a 3 from here. 30 times. Does that work? Yeah, it does. 36. That's too close. We need a difference of 72. What else can we divide out of here? Well, 108, I'm going to, it's 20 times 54. I'm just showing you some strategies that you can do. Breaking up numbers, 2 times 10, 9 times 6. So this will be 2 times 2 times 5 times 3 times 3 times 3 times 2. And now I'm going to have to put those numbers together into 2 groups so that it makes a difference of 42. Yes?
Is that supposed to be 10,800 instead of 10,800 in the brackets?
I took out factored out a 10, right? So that's how it got to a smaller number. So now I'm going to just see if I can put together numbers here that have a difference of 72. I'm going to take the 3, and the 2 and make 18. The reason I want 18 is because I know that 18 makes an even number of 42. So I've used up the 2, the 3, leaving with 10 times 6 is 60. Is that a difference of 42? It is. Okay. So we'll go S. It'll be minus 60 plus 18. Would you be asked to factor 1 that hard on an exam? No. Then they would give you a calculator to do that. But just showing you some of the strategies that you could do to get that. Now when I split this up, I get S is equal to 60, or S is equal to negative 18. Based on the question, that's another thing you're going to have to do with word problems. Our non-permissible values, we always have to check to see if we have any boom values. In this question, S can't equal 0 and S can't equal negative 30. So both of those answers don't match up with our non-permissible values. However, the context of the question. When was the last time you drove negative 18 kilometers per hour? Never. Okay. So that one doesn't make sense. So the answer is 60. We go back to our question. What does that mean? His speed from Edmonton to Grand Prairie was 60. His speed on the way back was 90. So this question, of course, the factoring was really difficult. Could probably go to, with those big numbers, use the quadratic formula. But solving for S, we were able to get 60, and we've solved the problem.